We're going to start with 29 here. The one thing I want to point out, you guys, anytime you've got it crossing at 0, that means x is a factor. All right? So you've got, and you can see that here. So one thing you want to consider is maybe take out that x to begin with and see what you have left. X to the 4th plus x squared minus 2. Now that by itself needs some more work. But we have this, and we have the box, and we have these two other factors, or two other roots. So x minus 1 means one of my factors is going to be x plus 1. So I'm going to start here. I've got x. I know x plus 1 is another one of my factors, but I'm going to use it down here on the x plus 1 kind of a box sort of deal. And I'm down to 4 compartments needed because even though it was a 5th degree, it's down to a 4th because I took out the x. Keep in mind, you have some gaps here. So you got your x to the 4th. You don't have an x cubed. Make sure you account for that, 0x cubed. You do have an x squared, a 1x squared. You don't have an x. Plus 0x, hugs and kisses, minus 2. Okay, uh-oh, can we see that? So we have everything we need here, and you have an x to the 4th power. X to the 3rd. X to the 3rd. Now, together these give me nothing, so I need to be able to cancel that. So this is a negative x to the 3rd. That becomes a negative x squared times 1. Negative x squared, but now these are going to come together and give me a positive 1. So I need two positives to take one away to leave me with one positive. So up here I've got a plus 2x times 1 is a plus 2x. Again, a 0, so I have to do the opposite, negative 2x. Those give me nothing. X times negative 2 will give me that negative 2x. The negative 2 at the end here remains. Now, if this is factorable, I'm just going to throw this one at you. Yeah, we could go through this process again and set it up with an x minus 1. But let me suggest factoring by grouping, which we've done. But I can take this, if it's a 3rd degree polynomial and I know it's factorable, watch what we can do. I'm going to write this out. X cubed minus x squared plus 2x minus 2. If I group these two together with these two, I guess this can't happen all the time, but it does happen this time, so it's another opportunity. What can I take out of this grouping here? I can take out an x squared, and when I do, what am I left with? X minus 1. And so here I can take out a what? I can take out a 2. If I say plus 2 then, and it factors, oh sure. So what do I get when I take out a 2? X minus 1. So I've got my x minus 1s here. X minus 1s, if I take them out, I'm left with then x squared plus 2. Now the x minus 1 is really a confirmation of what I already knew. That root of 1 meant that I had a factor of x minus 1. So let me put that next to its little buddies here. The problem is I have an x plus 2 that's the final deal. That is actually not factorable. So even though it says factor completely, or write in its factored form, this is the factored form. Okay? But it does also say find all the roots. So this is the factored form. The roots are relatively easy because I've already kind of identified them. That's one root. Roots are negative 1, 0, 0, 0, and 1, 0. However, this produces 2 more roots. What type of roots are those going to be? Well, we don't know for sure. But if I set that equal to 0, x squared plus 2 equals 0. I can either do the quadratic formula, but since there's only 2 terms, subtract the 2. Nice, you can contribute, that's good. X squared equals negative 2. What? Square root both sides. So I have x equals plus or minus the square root of negative 2. And to write that legitimately, that's kind of close to the end. What would I need to kind of remove? Remove the negative. So it's going to have an I involved. So it's going to be a plus or minus I times the square root of 2, comma, 0. And you can actually leave it like that. You've still got two different, a positive and a negative version of this, comma, 0. I could really have done the same thing, a plus or minus 1, comma, 0 to list these both together. But those are the, that's it.